Hello, testing my volume. Hello, Fiona. Just testing my volume here. All right. And I seem to have volume. Okay. I don't know if I need to increase the gain of my microphone. And I'm going to do the following. So while we're waiting for people to show up, what I'm going to suggest is if you have any questions, throw them in the chat or you can speak up and we'll just answer your questions as soon as I can. I'm going to here so you can see questions as they show up. That looks wrong. Caesar, SCEA, Caesar. No one, anyone knows how to spell Caesar like Julius Caesar, that would be grand to know that spelling. Okay. C-E-A. C-A-E. All right, I'll have a look at your question in a second. Yeah, right. Right. So I was wondering if it's David be able to with functions. Yep. But I want to see the practice is really helpful. Like calling them in main and using variables in different functions. Absolutely. So let's do that. So I'm going to do a Caesar, what's called a Caesar shift, named after Julius Caesar. I think it's one of the other Caesars, um, but it's one of the first types of cryptography. Now they use it for letters of the alphabet, but we're going to use just numbers in this particular case. Uh, and then using variables in different functions, sure. And what other things can we do? We want to do a min function. We have um, factoring, but we don't have loops yet. I'm just trying to think of good other functions we can do because functions can call other functions, which is awesome. In fact, functions can call themselves, which is a way of looping around things, which it's called recursion, which is going to get really weird. Let's see how we were doing for, oh, we should start. Okay. So yeah, let's do a whole bunch of functions. That's what the whole plan of today was. And also go over the general formula, uh, how things sort of look in code. Um, my number one rule that I always like overemphasizing for people, everyone always goes, my function should do a printf statement. No, it shouldn't. Functions, think of them like a tool or a cog in a machine. You make up the machine by putting a whole bunch of cogs together, putting all these different parts together. Very few of those bits of the machine actually do any kind of, you wouldn't see output from any of these bits of the machine or anything like that. Um, Very much like your program, if I am writing, let's say, let me think of an example here. Way back in the day, I think before some of you were born, it's very depressing that way, or just as soon as you were born, I was working in a company called CDDAPCO, not CDDAPCO, I worked at there as well, but Katoka Interactive. Katoka Interactive was a children's educational video game company. We did a game, Mia 3 or Mia 4, anyway, it was in C++. They were using another technology before that, but they decided to go with C++ in order to be extensible. So to be more powerful, so they can do a better game. And the problem that they had, and so, if you're writing all this code from scratch yourself, that's what our team was doing. One person wrote the library, the other two programmers wrote pretty much most of the game. Between three people, we wrote 500,000 lines of code. And it doesn't seem like that much of a scale from what we're doing here, but I promise you the difference between 500 lines of code and 1,000 lines of code is quite considerable, even if it's just doubling it, because the complexity explodes as you get more. Every line of code could make other kind of problems along the way. And if you have 500,000 lines of code, how many of those functions that you have in there, how many do you think actually have a printf statement in them? Like if you have a printf statement for 500,000 lines of code, you'd have thousands of printf statements just blowing by your screen at any given time. In fact, we never use printf statements. Why? Because you couldn't see them while you're playing a video game. It's a video game, it takes the full screen. And so the concept is you think of these as little widgets that all, data goes in, data comes out. What the data is depends on the person. Okay, so we're going to do a Caesar shift and we're going to see how that goes from there. Okay, so I'm going to yeah. So here's what a Caesar shift does. A Caesar shift, let me see here. The shift, I'm going to call it. I'm going to take in some integer. I'm going to take in an unsigned integer. Call it original value. I'm going to spit out an unsigned integer. And what a Caesar shift does is originally designed for war to hide your message. So if I have an A, I shift it over 5 spaces. So instead of an A, I go A, B, C, D, E, F, or 4, depends on what number I want to use. But it's any number of constant distance to the next character. So an A becomes an F. So and an H would be 5 characters further down the alphabet from that. A Z, on the other hand, or an X or a Y or any of these later letters, you loop around again. So a Z goes Z, A, B, C, D, E. A Z becomes an E. A Y becomes a D. An X becomes a C, right? You just count 5 and it loops around. That's what a Caesar shift is. It's a cipher. It's a way of encoding a message. So if the message was hi, the H becomes 5 characters for H, I, J, K, L, M. The H becomes an M, I becomes I, J, K, L, M, N becomes an N. I becomes MN. That's what you would see on the screen, or that's what they would write down on the piece of paper. Heck, you could even, if you really wanted to, you could even change what the space is evaluated to. We'll see this in action in a second. So every single character of the alphabet, you just wrap it around. And that's what we're going to be doing. And it gets kind of fun in that, or complicated in that way. And then to undo it, you just take away 5 and wrap it around the other direction. So if you give me, I think what it said, E becomes a Z. So you give me an E, I go -5, and it becomes a Z on the other end. And I don't need conditionals or loops or anything fancy like that. I just need math, which is nice. So here's what my Caesar shift is. I'm going to take my number, whatever number I get passed in here, from 1 to 26. Well, let's do 0 to 25, actually, just because of the math. Okay, and let's make a constant. Constant int, it doesn't have to be an unsigned int, constant int alpha size, that's the alphabet size. Alphabet size. I always forget if it's 25 or 26. Let's say, but if it's 25, by the way, let me know. But I always mix that up. And then we're going to make that's not defined. We're going to look at define soon. That's how I define. This value here is not going to change. I'm not allowed to change it. It's constant. Okay, so here's what I'm going to do. I'm going to take my original value. I'm going to take original value. I'm going to plus 5 to it, or maybe let's make a shift amount. Constant int shift. And let's do unsigned int just everywhere. Again, for those of you that are, what the hell is this unsigned int thing? Unsigned integers, they're only positive. I don't have that two's complement thing going on. So I don't spend half of my numbers being negative. It's only positives. It goes from zero, like if I have 8 bits, it goes from 0 to, let's say 255, right? 2 to the power of 8. Right. So 0 to 255, that's the numbers I can represent. With a signed bit, byte, sorry, with a signed byte of numbers, or 8 bits, then I can represent negative 128 to 127, right? Half my numbers are for the negative values. So signed versus unsigned gets me in trouble when I get above that 127. That's why I sort of want to keep it consistent. Okay, let's put a 5. All right, that's how much I'm shifting this thing by. Properties. Oh, I don't want to do it this way. I'm going to do it a slightly different way. This is what I should do that I'm always so lazy about, and I shouldn't be. Here we go. Yeah, just copy and paste this. This will get me to what I was trying to talk about before. So let me just put this all in, all my code in there right now, and then see what happens. And we can do it this way. And if I want to make sure I don't go over the 226, so if it's 0 to 25, those are the numbers I can represent, 0 to 25. If I get to 26, I want that to be equal to 0 again. I want it to wrap around. So when I get past Z, it's A is the next character. So I want to wrap it around. So output size. So what will this do? So I'm not expecting you to have come up with this off the top of your head or anything like that. But what will this end up doing? This will be my original value. I add, in this case, 5 to it. So A, B, C, D, E, F. So A is 0. Add 5 to it, I get F, or whatever I want to call F. If I go beyond the 25th character, that's 26, 0 to 25 is 26 characters in total. If I get beyond 25, I get to 26, it should be an A again. So that's what this little remainder thing is going to be doing, preventing me from going beyond the size of my alphabet. Okay, and then I'm just returning that number. Notice I have a return value because on the left-hand side of my function, I have this thing here. It is what I'm returning. This is the output. I have the name of my function, cshift. That's what it's named. And here's the input. How, this is the data that's coming into it. I have one value going in there. If I had a second parameter, I'd have a comma, and then the next value, and maybe the next value. In fact, I could make this even more general, and I'll look at that in a second. So let's make it more general in a second. Okay, so here is, oh yeah, let's do that. We'll do that in very quickly or soon. Notice at the very top, I have my prototypes. My prototypes are just stubbies. They're IOUs. They are the outline for what you're going to do. I'm going to have this function, then I'm going to have this function, I'm going to have this function. I'm not defining them. I'm just saying I'm going to put those in there eventually. Because this program is compiled from top to bottom, one after the other, one thing after another. If I want to use this C shift function, I either need to define it up here, or I could just say, I owe you one function called C shift. So now main can call C shift. I don't care which order these things are in because I have all my prototypes at the top, other than main, right? All my prototypes at the top. So I always know what functions I have available to me. And then I need to make sure they're defined somewhere in the file. I normally define them below. By putting prototypes at the top, it means I don't have to worry about like, oh, what's the order of these things, right? I just put them all at the top. Hopefully that makes sense why we have prototypes. That's, you don't need prototypes, but it's good coding practice. It's a bad habit of mine to not have them in there simply because I need to worry about look the order of these things are defined. I don't want to do that. Okay, so this thing takes in some input, spits out some output. I'm going to do one other thing besides this. Um, the general term for these sorts of things is a shift cipher. We're going to call it a general shift cipher, and then I'm going to call a function. Um, so it's not in shift out. I'm going to have and you're probably wondering, why am I doing this as well? Well, because I'm going to do it two different ways. I'm going to show you, not cheating, but we're going to get to that in a second, of functions calling functions, just to show that we can do it. Okay, so we're going to get to that later. I want to code this thing up first. So let's do this. So what I want is some value. We can get the value from the user. Let's get the value from the user. So if I have my fingers on the right keys, printf, value. Okay, let's use scanf, but I would normally do this. Scanf underscore s. I have a big, long, very long-winded discussion about this. The underscore, these, by the way, printf is a function. Scanf underscore s is a function. Main is a function. They're all functions. Everything we've been doing has been functions. We just haven't been like making our own before. Okay, scanf underscore s. This will take in some kind of string. Normally that I'm going to put an integer inside of it. So that's what it's expecting to put an integer in whatever this next value is. The next value is going to be, I have put this ampersand thing. We'll get much later in the term, we'll figure out why there's an ampersand there, but some value. I'm going to need a value for it. So we should make it unsigned. So U for unsigned. And if it's not, I find out the hard way. I'm going to give it a default value. Just I don't like leaving things not with defaults. If I don't put a default in there, I don't know what I get. In Python, you'll get a default of 0. In Java, they'll set some default. And C goes, no, I'm not even going to bother putting a value in there, and you'll just get whatever garbage was there. Okay, so I like giving defaults all the time. Original value. All right, I'm going to need. Let's see what I need for this. It should be telling me what I need to include. IO, I do believe. This is me memorizing something. I don't like memorizing things, so. Do I need the .h? Yes, I do. Okay, so I don't want to be plowing away without knowing where I'm going with this. It's the original file. Here we go. Value. All right, so I'm asking for a value between 0 and 25. I get an unsigned integer that gets put into my variable called original value. And then I'm going to call my Caesar cipher. So unsigned int new val. And this is going to be C shift. All right. And then I'm going to do some kind of printf statement here. Is converted to you. I'm going to add some more stuff to that afterwards. And for my printf, it takes in a whole bunch of different parameters, one after the other. So the string I'm going to output, and then each of these little percentage something or others, all of these things here in the order which they appear. Okay, so what's the first one? It's original value. And this is new value here. Those are my two different values I'm going to put here. New values here. Original value goes over here. Okay, let's compile it. Let's see what happens. Maybe I have a compiler. It's okay. Okay, it compiled. Again, I don't know if you've seen Discord. Sometimes it pops up every once in a while, people asking for help. And it's perfectly normal to ask for help, but notice I did not run my program. I compiled, I saw if I had any errors. If there was no errors, and only then do I try and run it. Because if you run it, if you compile and run at the same time, which is an option, if you just compile and run at the same time, what ends up happening is if it doesn't compile correctly, you're either looking at your old code, the old executable that you have, because you didn't replace it, nothing was replaced. Or if the executable wasn't there, it says, hey, you can't run the program. We're looking to hook up. You get some weird message. Because if you have a compile error and you ignore it, and then you try and run your code, you either looking at old code on old executable, or there's no executable and it barfs at you and yells at you for that. In either case, you don't want that. The better thing to do is compile, make sure it works. Once it works, move to the next step. Okay, so let's see this thing in action. I got to move this over. Sorry. So somebody, just to wake you guys up, somebody give me a number to put in here. I'll wait. It's some number between 0 and 25. 12, great. So what would we expect? 12 plus 5 on this case, 17, right? I like testing my hypotheses. Hey, there you go. Great. And I'm done. Well, the only point of a Caesar shift, by the way, or a shift cipher is if we can reverse engineer it. So unsigned int reverse C shift. Oh, okay. I want to have a variable name that I know what it means when I look it over. I sort of understand what this is going on here. In this case, I want the Caesar value, the cipher value, whatever, C value. Seems reasonable, at least for a name. I don't want long names because I'm lazy. I don't want too short names like A, B, C, or D because I won't know what the hell that means 5 years from, 5 minutes from now, let alone 5 years from now. Right? I don't want something that I'm going to forget what it means later. I want a variable that is fairly, like consistent, that makes sense, that's easy to type. Those are my three big things that I want. So I could call it something other than C value. I could call it, encrypted value or something like that, but C value seems fine for me. Okay, and again, I would normally for all of these things, I'd have comments on every single one of these functions, right? I'd have some kind of, explanation of what this thing does, especially down here. Okay, so let's copy and paste to your friend. Okay, there's a comment. Explains what the heck my function's doing. Okay, what's this going to do? It's going to be the same thing as last time, or about the same thing as last time. But instead, I'm going to take my original value, subtract 5 now, and make sure it doesn't go out of bounds. Seems reasonable to me, right? So if it was, if it goes to -1, it suddenly becomes 25. If it goes to -2, it becomes 24. That's how modular arithmetic is going to work. Reverse Caesar shift. Okay. And I'm going to do this because I'm lazy. 2, and I want a new value is going to go into C rev shift, reverse Caesar shift. Oh, rev C. That's why you need good names. You want to mix that up. Reverse Caesar shift. The new value is going to get a new version of original value, converted to black and back to. I want something that can follow along. All right. Hopefully so far so good. So I'm calling one function. The input is going in here. The output always is caught by something else. So things go in and it gets fired off the side here, like meat going into a meat grinder and just firing off sauce. All right. So it's going in from the top or going in the parameter list, and then stuff comes out the other end. A function effectively only returns one thing, one value at a time. Now, that value could be a struct, which is a whole bunch of different data wrapped together. You can do other things with pointers, but the fundamental concept I want people to get their head around is you cannot return multiple values. In fact, as soon as I say the word, oh, there you go. I got an error in here, so let's fix that. There you go. As soon as I see the word return, I'm done. I can't do anything else. I can't change anything else. I can't do any more lines of my code. If I have return and then I have, let's say, in I is equal to 3, I multiplied equal to I, let's say, so we're going to square it, and then return I, always going to be a positive value. I'm not even sure if this is going to compile. Let's find out. It should warn me. No. And we're going to put a breakpoint in here just to see this in action. Because why do I want to see this? I want to show you, you're not even going to do these lines. They're completely a waste of your time. Okay. I'll even put a comment down here. Waste of time. Oh, and again, all this code is on the shared code repository. All right, let's run it. So let's try 12 again. Because we know it goes 12, 17, it should go back to 12 again. And here's my breakpoint, hopefully. All right, so 17 minus 5, 26. I'm hoping will give me back 12. And then the next step is I want to go one step further. So I'm going to step over, I'm going to the next line of code, and I'm done. What? As soon as I hit that return, I get the hell out. It gets you completely out of the function. No matter where it is, no matter where it is in the function, you say the word return, you are done. And some people have trouble getting their head around that idea, right? So all those other lines of code are complete wastes of time. They don't do anything. You can't do anything with them. Okay. I'm just going to continue and see what I get. Value 12 is converted to 17 and back to 12. Great. Let's get rid of this comment here. I'm going to also comment these. All right. Next question. What should I be testing? What kind of values do you want to throw in this thing to make sure that they work as expected? So we are saying it has to be between 8. Great. Perfectly fine example number. I would like to say some other values besides 8. So we have 8. Well, that's good. That's going to give us something very similar to 12, but 8's a great thing to test. I have to do something really nice about this. Okay. Uh, 8, 8, that's 13 to 8. Great. Maybe I don't need the fancy thing that I was doing before. Here we go. What else could I do? 24. Why 24? It's a very nice example, Fiona. That's perfect. That's exactly what I was looking for. Why 24, though? Exactly right. When you go to 24, you're going to go over the limit of what your characters or your values can be. 25 was the maximum, and you'll loop around again. And then you also reverse it afterwards. So you're really going to test your code with 24, right? Just 8 alone doesn't tell you if you handle the case where it wraps around. You need a case when you test wrap around. Heck, I'd even throw in maybe a negative number, but the negative numbers are like a negative number is going to really screw things up because you're not going to get your original number afterwards. You pass in a number that's a negative number, it's going to convert to some value between 0 and 25 because that's what remainder does. And then you're going to reverse engineer it again. You're going to reverse it and you get a different number than what you originally started with because your original number wasn't a valid number. So if you give me an invalid number, things won't blow up, but you're not going to reverse engineer and get the original value you had. And that's fine. We told them between 0 and 25. If you give me garbage, I give you garbage. Stop giving me garbage, essentially, right? That's what we're looking for. Nice. So let's run this and okay, I got to keep on moving this over. Sorry. Um, 24. 24 converts to 3 and back to, oh, whoa, I got a bug. Nice. So 24 converts to 20 to 3 or 25. 0, 1, 2, 3, and back to 20. Ah, that's something weird. 3 minus, I'm assuming that my error has to be in my convert back again. So 3 minus 5 gives me negative 2. I want to put breakpoint on that thing. Or actually, let's set a value. Unsigned int red val. I call it red val just because return value. I'm lazy. In case you're wondering what all this red val crap was everywhere. All right. All right. Return red val. Okay. I may want to see what the heck I'm getting in here. Okay. And I want to put a breakpoint on here. Either I have a big bug in my code and I just don't realize it and I want to find out what's so 24. We're going to go step 1 over. So red val here is 3. So 3 minus 5 should give me negative 2. Negative 2 mod 26. Let's see what negative 2 mod 26 is. Why is it negative 2 mod 26? Oh, I may have to deal with that in a different way. Because I don't think my math is going to work. It's actually looping it around based off of it being a 250, being a 4-byte number. Okay, I need to do something different. Okay, how about this? I get this value. I'm not going to do the mod yet. So let's move that over. Red val. Fine. All right. So I shifted it down. It's down to -2 now. I'm going to say retval is equal to retval plus retval plus alphabet size. So it was -2. It is now 26. It is now 26 minus 2, so 24. That would do it in this case. But wait, if I had 20, if the value was 12 and I converted it, what would happen? Well, now it's way too big. So I need to do that remainder thing one more time. Red val, red val mod. That should make the math work, right? So I've added an extra red val, but that goes away if so I'm making sure it's positive. So if it was -2, it suddenly shifts back up to 24. If it was 12, it's 12 plus 24, so 36. And then I mod 26 to put it back to 12. All right. Hopefully. And now I need to test a bunch of cases because I thought the original version would actually work. But then we tested it. All right, let's run this thing. Let's see what happens. I want to try first. I want to try 24 again. Let's see what we get here. I'm going to step through my thing. My ret val is some ridiculously large number. Why? Because it's an unsigned integer. It's actually -2. Ret val is equal to 24 because I added 24 to it. And then it's still equal to 24. It should not have changed. And I've returned 24. All right. How about the other one? Let's try our 8 again. 8. Okay. So my ret val is originally equal to 8. So the original value going in was 13 minus 5 gives me back my 8. I then ret val is equal now 34 because I added 26 to it. And then I do this again, and ret val should be equal to 8 again, and I'm good to go. Right. All right. So that's useful to know. My point being, what we could do is, what if what kind of tests could I make? Well, one of the tests I might want to make is maybe I want to put an assert in here. I like asserts. You don't have to love them, but I love them just the same. I'm not standard IO. All right, assert.h. And yeah, that'll remind me to hit this thing right here. Scanf. All right. We're going to assert that the reverse C shift of the C shift of 8. Let's walk that through that in a second. Okay, hopefully that's enough parameters. Parentheses. 1, 2. So what is this? This is 8 goes into C shift. That returns a value, which is this thing right here is now equal to the value 13. Because the C shift of 8 gives me 13. So that's what this thing here is. 13 going into reverse of C shift gives me back my original 8. And I want to say is equal to 8. Ideally, you would want to be able to say any valid number, put it into this thing, you should get the same value back. So what I want is, I can do this. Notice, by the way, that no matter what I do, here, I don't want to use the scanf. I could use the scanf, But if someone gives me garbage data, it's going to blow up on the assert here. I'm saying if I put in the original number, convert it back, I get the original number. And I can put a whole bunch of different hard code, like number examples in there and see what my code does. And I'm not asking the user to type in 4 different numbers. I can test it myself. And if that, I'm worried about the performance or something like that, all this extra code, I could comment at that line if I wanted to. It doesn't cost me anything to have this line of code in here. It says, I'm going to take this number, shift it, put that number into this new function, this other function, the reverse of the C shift, reverse it. And by the way, it better be equal to 8 or yell at the person. So if the reverse, the shift and then the reverse shift do not work as expected, blow up. And I can try 10 different examples here. Hardly cost me anything to type in. I'm not typing it in each time to test code. I can just run this. So instead of getting this cout statement here, like using scanf everywhere, I can just do a bunch of asserts. Lets me test my code really efficiently. Leave them in there. That doesn't hurt your code at all. And the TAs know that you're testing your code. All right, I'm going to put a number in here. All right, and I'm going to use 15, let's say. Notice I don't get any feedback for the other one. That's fine. It's not changing my code. It's just testing stuff. Good enough. I know it works. I know it works for 8. I know it works for 24. Because I have these extra tests in there. All right. I want to do a couple more things. One of them is this. Actually, let's put the S back in there and say, just to be clear, I could put a 1 in here to say, yeah, I'm having exactly exactly 1 value in here. Now, ideally, not used for the format string for this kind of thing. Why? Because I don't need it. But it allows me to do it. It shouldn't actually change anything. Number here, let's try 12 again. All right, that works. I don't need it because I'm only putting things in an integer or unsigned integer. Later on, when we do with strings, when we do with text, like hello world, when we did the hello world earlier, I want to say how big can I put this? How big of a value can I put in here? Because if I say I'm only allowing 10 characters to be put in, message can only be 10 characters long, and I put 12, it's going to start stomping. It's going to start putting data in the wrong place in some random part of my code or in some other random variable. It's bad. It just merrily goes about and just doesn't do any error checking or anything. C is famous for just letting you hang yourself. C allows you to do all sorts of things you wouldn't want it to let you do because it does no error checking because it wants to be fast. It's so fast, it's like not installing seatbelts in your car because the time it takes you to put on your seatbelt slows you down, right? There's no error checking, there's no safety precautions, no nothing. It's just as fast as it can be, which makes it very, very difficult to debug if you're not painfully sort of regimented in your approach. So in case you're wondering, that's why the underscore S, because it's trying to prevent people from doing stupid things. If I do the scanf, just scanf, that's just, I'm very lazy. Here we go. And now, Visual Studio should yell at me. There we go. It's yelling at me quite nice. And we get this nice little error message here, the CRT secure warning thing. So nothing says it's broken. It's just actually a warning, and yet it prevents me from compiling. And it's so frustrating. So here's what I need to do. Very, very top line before I do anything else, because this will actually change how everything else gets compiled, honestly. Define underscore CRT secure no warnings. That's it. Don't put anything else. Don't make it equal to anything. Just define it. And now it works. And now I can put in some value. I can run my code just to make sure it works. So let's put in 8 again. Google Drive just popped up at the same time as me trying to push enter. All right. Anytime. There we go. Okay, it worked. So if I have no choice but to use scanf on not use scanf underscore s, fine. You need to put this CRT secure no warnings thing, but the underscore s is to save you from yourself, because I know I've done it enough times where I tried to write a message that was too long for the array where I'm putting all of this, all the message, and it just merrily goes on, starts stomping on random data, and you have no idea what it's going to do to your code. So it's just as a general safety precaution, underscore s is your friend. All right. I wanted to do, first of all, I want to check to see how people are doing. I've been talking a lot for like a couple simple functions, but we can, oh, let's actually do it this way instead of this format that I was doing here. Let's do a proper, I hope it's not going to confuse people too much, but let's see here. To num. There's really no need for this function whatsoever, by the way, just in case anyone's confused. I'll call my num. Remember, we have a character data type that exists. Okay, and this is num to char. All right, so if I pass in a number, it spits out a character. If I pass in a character, I get a number. So if I want to convert pi over, what I could do is convert to a number, pass the number to the Caesar shift, and then so convert it, and then get the character equivalent of that, and then convert it back. I can do a whole bunch of weird, quirky things like that. So let's try that. Write a case alphabetical character. And instead of this, I'm going to still use my scanf. It's going to be a character. And I don't want original value. I want char. Oh, original char. Equal to, let's give it some default value. So I can make a character. Characters have single quotes around them. Strings, like big long text messages, have double quotes. They are radically different. Under the hood, a character is just represented as a number. It uses what's called ASCII. We'll be looking at that. But we need some way of converting letters we type on a keyboard to computer language. So that's what we use. ASCII is A is equal to this particular numeric amount. B is equal to this particular numeric amount. In fact, it's the next number over. C is the next number over from that. So A, B, C, D, all the way in the alphabet is just one character over for each one of these things. Okay, so I'm going to take in some value here. I'm going to put in original char. I'm going to get rid of this because I have no need for it. All right, and then what do I want to do? I would like to, let's try and do it this way. I'm going to do my Caesar, instead of just my normal Caesar shift, I am going to take, instead of an original value is going to be wrong, it's going to be original char. I'm going to How do I want to do this? My functions can call functions. That's fine. So let's do another example of this. So what I'm going to do is I'm going to take this character, convert it to a number, pass it into my Caesar shift, get the new number, convert it, do the reverse again, and then convert that number, the final reverse, the reverse number, back into a character. So let's see how I want to do this. I have my original character. I want to char char to all right. This is going to take my character, convert it to my character, convert it to a number, shift it, put that value in here. Afterwards, I'm going to reverse this whole thing, and so I'm going to take my new value, I'm going to convert it, and instead of original value 2, I'm original char 2. I'm going to do this. So okay, what if I wanted to also do another one of these? Let's do or encrypted character. Okay, and then I'm going to take that new value, I'm going to convert it back. So it's going to be number to char. So I'm going to convert it back to a character. So I have I convert to a number. I do my shift, I add 5 to it, becomes F. So the value of A is going to be a 0. I'm going to do my shift and then convert it back. So E and char would be F. The original value here would be, say, the original character is A. E and char would be F, and original char 2 would be A again, because I'm constantly I'm doing my shift with my numbers, and then I'm converting it back to being a character. Yes, I want to show examples of functions calling functions when different kind of inputs. It's intentionally trying to be weird and roundabout. Okay, original character 2. Okay, we're going to convert this char. All right, great. Now I just need to define these things up here. Oh, by the way, I should be able to compile it. Hopefully it can. Oh, I have something wrong. Formatting a string. That's weird. This is normal. I don't have those functions defined yet. Great. Let's define those functions. I've already copied them, so here's me just pasting stuff. All right. So my character, what I want to be able to do, and I can honestly do this, and I just happen to know this, is I want to find out what the numeric value is. And I know that B is 1 character greater than A, and C is 2 characters greater, and D is 3 characters greater. So what I could do is say my char is going to be some unsigned integer, and I'm going to shift it down. So uh, what I can do is this: my char minus the value for the character A. I can actually do that. So if it was C, that value is now 2. That's the difference between the A and the C. And what I might want to do is What I might want to do is just make sure that I do this remainder thing like I've been doing before, just to make sure I have a safe value. Next thing. Okay, it's always going to be make sure it's a safe value. Return that value. All right. Why? Because I can't. Okay, this is going to convert it for between whatever the character value A is. Or let's say I have a C coming in from my chart. It's going to be, instead of a C, now it's going to be the number 2. That's all this does. If it's something outside of the realm of normal or acceptable characters, I can deal with it a different way. I could have also done the following. Search my char is greater than or equal to character A. Search my char is less than or equal to the character Z. You give me anything other than an acceptable number, blow up in my face. So I know that I did something wrong or the person put in bad input. Find the error right away. That's a really brute force and ignorance way of doing things. Another way I could have done it is I could have made sure it was an acceptable value. And if you don't give me an acceptable value, keep on asking the user for proper input. That's a more elegant solution to it. But we don't have conditionals yet. Okay. So blow up if this is not true. If it's not between A and Z, including those characters, blow up. Okay. Then I would need this part here. I just return ret val. But well, I'll leave it in. Doesn't hurt. All right. The next function, I'm going to convert the other way around. So I can do an insert here. Insert my num is greater than 0. Greater than less than bit size. Right. I have some valid number here. Okay. I want to then, what do I need to do? I'm going to add that lowercase a to whatever the number is. So if it was 2, it is now a plus 2, which is C. I've reverse engineered it. So return plus character, or should do a plus character minus. Yes, you can do this. We get used to it after a while. Because it's just a number under the hood. Okay. That's all this thing is doing. It's not really doing much at all. It's just doing one tiny little bit of math. Let's make sure it all runs. All right. Here goes nothing. Let's find out. Okay, and we're going to put like lowercase alphabetical character. Well, we've already tried C, so we've already given examples of using C, so let's use C again, just in case. Lowercase c, by the way. I'm back to, see, weird things happen. All right, let's have a look at this. Definitely with my numeric conversion here. So I got to figure out what's going on with this character to number. I want to maybe look at that. I have a bug in my code. Great. So I'm going to put original character in here. I want to see what that original character is afterwards. I don't know where my bug is, so I'm going to just see what I got. So C, it is the value C, original character is equal to C. The numeric value is actually the number 99, by the way. I am going to original character 99, this 99 goes into character to number. So let's walk into character to number. I'm going to step into my function. All right. I want to double check. Yeah, it's this C. Okay. I'm going to go a couple steps in. Okay. Return value is my character C minus 97. See? This is 99, this is 97. It's ret val, value 2. Ret val is equal to ret val minus this, so that's still 2. Turn ret val. I then have, so this, the value going into C shift should now be the value 2. Step into this function. I want to see how that looks. So I mean, this function yet. Oh, there I am. Check out the value here. It's value 2. I'm going to add 5 to it. I'm going to do the rounding thing, which we've already tested. Okay. And the reason is it's returning a value of, that's not the reason. Value is number 7. Okay. Number 7 going into num2 character. We'll look at that. Okay. So num2 character is 7. This is 97 plus 7, which should be 104, right? 104, which is the letter H, character H. Probably have something really stupid in here. Oh, it is something stupid. See? Copy and paste and bit me again. It should be original character, not original value. It's original character. I don't even have something called original value is set to 0 at the beginning. Original character 2, I got to make sure that that works right. So, I word. Okay, in character. And my reversing of the new value gives me, it does not give me a character. Okay, I got 2 bugs in here. So this thing should give me I was just rushing through and I didn't think it through. All right. This takes in a number, it spits out another number. I need to put something on top of that to convert it back to a character. So now I should put around it num to char character around this thing. Fine. Oh, I've got to stop soon. Sorry, folks, I'm going long. This should be a new character in here if I'm doing my job right. And the original character is there. All right. Once again, let's test this thing out. Okay, so we're going to put C and back to C. Great. I want to do, let's do Z. Or Y, actually. We've been doing Y for a while. So Y, back to D, and back to Y. Great. Testing the code. That's all I'm doing. All right. I want to do one other thing. Hopefully, I know I'm going more than an hour, but sort of an hour and a half. No, it's actually only an hour. So I don't want to go too long with you guys. I'm hoping that makes some sense. If you need to take off, you can. I'm just going to throw one other function in here. Let's do char C shift C or character C shift char. All right. And I'm going to have a character going in. Char. Rev C shift char. The only reason I want to show this is because I want to be able to do things a little bit easier for myself. All right. I'm going to take my character, convert it to a number, shift it. Okay. So, okay, well, I'm in the middle of a talk, so I'm not going to answer that Discord quite yet. Okay, so I'm going to convert my character to num of my char, And in front of that, I'm going to the that thing. And then on front of that thing, I'm going to go num to char of this whole thing. Okay, that should be a character being returned. It is converting it to a number, shifting the number, converting that number to a character. And this thing is going to be doing the reverse. So I'm going to return. I'm going to have char to num shift char. And then on front of that, I'm going to reverse my shift, rev the shift of this thing. And then afterwards, I'm going to convert it to a character. So num to char. Why would I want to do this? Well, that's going to work for me. Why do I want to do this? Because I'm going to do it this way. Let's do an assert. Assert. I call this let's say the letter C, just some example. Rev C shift char. So what this should do, and I need this whole thing equal to letter C. What this thing should do is it takes a character, converts it to the new format. So C goes to an H, and then afterwards and reverses it back again, goes back to a C. And I'm checking to see that it goes back to being the original value. I should also maybe test that C. I might want to test something like insert C shift char of C is equal to, let's say, the letter H. D, D, E, F, G, H, right? That's what I would expect. So if I do this Caesar shift of a character from the letter C, I should get H. If I go from the letter H back to, I should get back to a C, right? That's what I want to, I want to just test some stuff out to make sure my code works. Because we've already encountered cases when it does not work. That's why we test our code. All right, let's do Y, let's do Z. We haven't done Z yet. Forward. Let's put F, okay, and everything works and nothing blew up. The reason I wanted this thing is I wanted to, the only reason I made these two functions right here, because I wanted to show functions which are calling functions. It's okay, and functions can call functions which can call functions. It doesn't matter. You just have to sort of build it up in your head. So you do a little bit of a function, build something on top of that. You can build something on top of that. You can wrap functions around, because what I really want ultimately is I pass in any message and I go character by character, converting each of the characters into this new message. And then I output that to the screen, let's say. And then I take the original message, and this converted message, this encrypted message, and I pass it into this new function that goes character by character, converting it back to the original message. But I only get that if I have something like functions, because I don't want to be doing this all in a main method. I want you to be able to pass in any function you and any bunch of any message you want, and it just converts it for you. And you're not worried about like, oh well, on a Tuesday it doesn't work like this. I don't want it all in main. My head will explode. It's too complicated. I want a little bit, test it. Do a little other function, test it. See if I can string together a whole bunch of functions, test it. Do a little bit at a time, and then you can compose much bigger, more elaborate things with functions of function, with calling functions, which call functions. That's why we're doing this so early. This is just one example of, and way more elaborate than the assignment. I'm hoping it wasn't too confusing here. the idea that a function can call other functions, and you can just compose things by building up these little tiny Lego blocks and building more and more elaborate structures as a result. Okay, I want to see if, I know I went long. I want to see if there's any questions before I let you guys go. That was a lot of talking about various things, but I'm hoping it covered everything that you might be worried about, including functions that don't just take numbers. They take sometimes characters, they spit out a number. Sometimes they take a number, they spit out a character. And I have functions calling other functions. Oh, can I do one more thing before? Here we go. Just want to see this in action or show you this in action. All right. Notice there's a variable called mychar up here. There's a variable called mychar here. Notice there's no error. When I'm in this function using a shift char up here, it doesn't care what you're doing. That mychar is for this function. When I'm in main, this mychar is for this function here. It depends on the context. So you can name the same thing, you can have the same variable name multiple times, and it depends on where it's located to tell you which variable you're using. It solves ambiguity based off of where the variable is. Everyone's really quiet. They were just hopefully learning by osmosis or being near me rambling on about functions a bit too much. And I don't know if anyone's going to ask any questions right now. So let me just stop sharing for a second. I'm hoping this made sense. There's not many of you here right now. And I'm just going to post this online as well for people to look at. But if you have other questions or you want other clarifications, just let me know. Okay.